Today I wanted to talk briefly about permafrost, and we'll be actually returning to this in Module 5. But in terms of climate modeling, permafrost is one of the largest unknowns. Permafrost is land or ground that has been permanently frozen for at least 2 years. And as you can see in these diagrams here, it lies below the surface. So you can see in the top here, this is the icy ground that's frozen. And above that is this active layer. Okay, so it lies slightly below the surface of the Earth, not far, and so it is really it's really sensitive to warming. Okay, so it's a massive amount of land and a massive amount of ice, and actually because it's formed via bacterial processes, permafrost is very rich in CO2 and methane, CH4. So there's about 24% of the Earth's surface, of the exposed landmass, I should say, has permafrost under the surface. That's major amount, and it's obviously located at high latitudes. And as you've learned over the last 2 modules, this is area that's warming more rapidly than lower latitude locations. So permafrost is already warmed by about 2 degrees centigrade, which is greater than the warming of the Earth. As I said, it's very rich in CO2 and methane. In fact, permafrost holds 1,500 billion tons of carbon, which is double the amount of carbon in the atmosphere. So it has the potential to be a major player in global warming. Okay, so when you look at permafrost that's melted, you can see these ponds, these frozen ponds here. This is area that's had melted permafrost. And you can see in this diagram here, when the permafrost melts, the land sort of subsides, and that's why it looks like this. So this is the permafrost layer that's gradually breaking down over time, and you basically emit all of this CO2 and methane that's locked in the ice, and then the ground subsides. And over time, as we continue warming the Earth and warming the high latitudes at an accelerated pace, what's going to happen is the intake of carbon, the blue arrow, will gradually decline relative to the output of carbon, the emission of carbon from permafrost in this red arrow. So the big question is what's going to happen in the future. The active layer is gradually becoming thinner. Okay, so this is a layer where the permafrost melts, melts in the summertime. So this is permanently frozen. In the wintertime, this area is frozen. I should have clarified that earlier. The active layer is frozen, but it melts in the summertime. So these are summer photographs. And what's happening in this active layer is becoming thinner and thinner and thinner over time. Wait a minute, is that right? Thicker and thicker and thicker over time because it's melting, more and more of it's melting. So the active layer becomes thicker. And even if we limit the amount of global warming to about 1.5 degrees centigrade, permafrost carbon will lead to an additional warming of between 0.13 and 1.69 degrees centigrade. So this is what we call positive feedback, because what's happening here is you melt the permafrost, you warm the atmosphere, and then you melt more permafrost, and then you melt more permafrost, you put more CO2 and methane into the atmosphere, you warm it more. And so this is a positive feedback system. All right, so that's kind of a quick and dirty overview of permafrost, and you'll learn more about it in Module 5.